For question 6, we can actually just pick up from where we left off in question 5. Right now we've got two variables in the model, and by clicking on the add here under the effects summary, we can do the addition to the model of variables, or we can remove them right here without actually going through the whole process of specifying the model again. So this is a very convenient thing that JMP has given us here. So I'm going to click on add. And so which of these variables might actually improve our model? So it might be that we have a difference according to year. It could be that a difference according to month. So bad weather in July might not be as big an effect as bad weather in February. So let's go ahead and click on month for starters, add that to the model. And then we can see, okay, did the R squared go up very much? Do we still have a significant model? Was month actually a significant variable? If we look back up here, we can see month was, it looks like month is even more strong than weather and high temp at this point. All three variables are still significant. The whole test is significant. The R squared, actually forget that lack of fit. These meant to look at analysis of variance. The overall analysis of variance is still good. The model is good, and if we look down at the effect test, all three variables, that's the same thing that we're seeing up here, actually. So we have still a slightly better model. RMSE has come down a bit, but we could still possibly use some more variables. So let's go ahead and say add. So we added month. Let's see, the day of the month, maybe the weekday would make a difference. So let's try adding that. And so for weekday, what do we got here? We have, yep, it's still significant. It's even more significant than the weather and the high temperature, but everything is still significant. Are the residuals getting better? Yeah, they look like they might be getting a little bit better. And our RMSE has come down. Our R squared adjusted has gone up. So we can still keep searching. So let's say we're going to say add. And we see inside park dollars spent. So let's try that one. Let's add that. And all of a sudden our R squared shoots up to 0.83, which seems to be one of the best that we've gotten so far. And let's see, is everything still significant here? Yes, they are. All of the variables we have. So at this point you might be saying, wow, this is really fantastic. Look at how the residuals have gotten much more normal at this point. And so you might say, yeah, we've really done a lot by this. The problem is that we do not know this number until the day is over. And we're trying to predict the attendance before the beginning of the day. So if we use this in the model, we'll end up with a model that cannot be used in practice, cannot be deployed. And so this is an important predictor. It says that when we have a lot of people in the park, they spend a lot of money. But in fact, it does not help us with this problem. So we better say undo and get rid of that. So let's go on to add. So let's see the inside total attendance. We want to skip all these attendances. Let's see what happens if we say other promotion yes. We click on add. And yes, our R squared goes up a little bit, but now you were supposed to remember what I directed your attention to. We only have 354 observations. So we've cut out 2/3 of the data at this point, and we haven't really helped our residuals very much. So let's undo that one. Let's see what we got coming up. How about Halloween? Maybe on the Halloween promotions we have a lot of extra attendance, so we can try adding that. And in fact, once again, it looks like our residuals have changed dramatically. We're up to an adjusted R squared of 0.64. Our root mean square error is down to 565, and we still have 5 significant variables here. So that's doing pretty well. And let's see, is there anything else left to add? We can try adding some of these consumer confidence indexes. I'm going to add all 3 of those at once. And let's see if those have any influence. And we say no. In fact, the p-values here are too high. They play no role whatsoever in the model. So let's undo that. So it looks like this is the best model that we can get. So again, it passes all of the technical tests. The residuals, although not perfect, they're looking fairly normal, except you can still see that we have kind of a V shape here. And so it may be that with the variables we had, we could not get a model that really was taking into account all the circumstances that predicted attendance at the park. We can explain about 64.7% of the variation using these variables. We have an overall significant model. We have 5 variables here that are statistically significant, so we're passing the technical tests. But when we come to our root mean square error here, we're now at 565, which means that we didn't get to the 300 number that Brittany wanted us to get to, and so we have failed to find a model that can ultimately help the amusement park.